Hello and welcome to the final one or two videos in the Blacksmithing 2.0 series where we've been working on a hook and chain link. So if you've followed us through the previous videos, we've made this hook and we are now going to come in and start attaching some chain links to it. So these chain links are going to be made out of 3/8 inch round stock. This is about 8 inches long. It gives us a good amount of material and is heavy enough that it won't be too challenging to do as your first forge weld. You can see each one of these forms one chain link for us. So let's start getting this hot. And while we're doing that, I'm going to talk to you guys a little bit about how to maintain your fire for forge welding. That does become a big part of this. So let me set this stuff aside, grab a piece of chalk, and I'll be right back with you. Let's talk about the fire and how to maintain a good fire, which is a key part of the forge welding skill. So if you've got a fire pot, hopefully it's going to look something like this. It may vary, have straighter sides or whatever. You're going to have your air coming in potentially up from the bottom, is the most common in the US. You might see side blast tweers where it comes in from the side, but same basic idea. So within your fire, you've got some different zones that we need to be worried about. Down here at the bottom, you've got your oxidizing zone. And I'm trying to draw upside down here, so I may struggle with some of these letters. Basically, down here in this zone, what you've got is more oxygen, more air than you've got fuel to burn it all up. So this is a very reactive part of your fire down here at the bottom. Going up a little bit from that, you get the neutral zone. This is, of course, the zone in between the Federation and Romulan space. So it's important to stay out of there or you'll cause international incidents. What it actually is kind of a balance zone. In this zone, you've got enough oxygen and fuel that all of the oxygen is going to be consumed by the fuel that's there, and it won't really get above it. So if you've got your choice between where your piece of steel is going to be in the oxidizing zone or the neutral zone is definitely a better spot. But above that, up here, you have the reducing zone. In the reducing zone, all of the oxygen has been burned as it's come up through your fire, and you get a very hot part of the fire right here with very little oxygen in it. In a well-designed fire pot, pushing your piece of steel in from the side is going to put you right in this reducing zone. You can get your steel hot here, it will get less scale on you, it'll have fewer chances of burning, and so that's really where we want our fire to be. And then above that, you might have some additional coal and stuff like that that's kind of providing just insulation to the fire and the steel. So we want to be coming in flat and get that steel as hot as possible. Clinker starts becoming a big issue. These forge welding fires that we're going to be working with when we make chain links are very hot fires. They burn a ton of coal, and all this coal we're using bituminous coal here. It's got silica in it, which is sand, glass basically, and that's going to melt and flow down into our fire. So let's take a look back at the anvil here, right? So we've got this piece of coal, it's getting hot, the silica is coming out of it, it's going down into the fire, it's melting, and it gets down here where it starts touching the outside edge of the fire pot, or it starts getting air directly on it, and it builds up in there, and that forms our clinker, like this piece right here. So this clinker starts taking up space at the bottom of the fire. This doesn't burn, it just takes up space. It prevents, it is taking up space that fuel should be using. And so as this clinker builds up higher and higher in your fire, all these zones in the fire keep rising higher and higher as well. And so you need to go in, especially when you're doing forge welding and you're burning a lot of coal very quickly, and on a regular basis, take this clinker and kick it out of there so that you've got good fuel the whole way down. What I start looking for in the fire, if I'm worried about clinker and I see some start showing up, is I'll look down into the fire and there'll be black spots. This is a terribly built fire right now. We need to do some repair work on it, but actually come take a look at it and it'll give you kind of an idea. If your fire starts looking like this is kind of a hollow fire where you're able to see a ways down into it. We just started it this morning, so we don't have a lot of clinker yet, but I'd be looking down in there and I'd see kind of crunchy looking pieces that are colder than the coal that is on fire. As soon as you can start seeing way down into your fire, it's time to pull it apart, get all that clinker out of there, and then rebuild your fire. If you're finding that you're really struggling with forge welding and it's just not going for you, it's probably because you've got a lot of clinker built up. Some smiths say that the clinker gives off gases and stuff that interfere with the forge welding process. I don't think that's really so much the case. My experience tells me that it's really a fire with a lot of clinker in it is not as hot as a fire without a lot of clinker, and not getting steel up to the right temperature is probably the biggest failure in forge welding. Let me rebuild this fire a little bit. We'll talk about how to make the chain link, and then right before we get to forge welding, we'll dive into a little bit on that forge welding process, how hot you have to get it, and the speed at which you have to do things. All right, so we've got a couple pieces warmed up in here, warming up the center of these bars, and we're going to bring these out and bend them into a U shape. So we've got a couple options to do that. One, we can take them here to the horn of the anvil, knock them around. We're a little off on the U shape here, so I'm going to take this, just hammer it down a little bit. I don't tend to worry a whole lot if the back end of these is a little uneven. Once they're welded together, that'll be a lot easier to straighten out. So just get that into a nice U shape. There is another way of doing these, which honestly is my preferred way. I'm going to put this in the fire here, grab my second one, and instead of going to the horn, I'm going to go to the Pritchell hole. I'm going to hold it with this so that I can see through the jaws of the tongs, drop it about a third of the way down, and then just bend it over. And if I've got it held sideways so I can see that steel, if I'm a little off, I can adjust where that is and try and get it pretty even here. That doesn't look too bad. Again, if I wanted to really get it 100% even, hold it, just give it a couple taps there. And there we go. You'll notice that I'm holding this steel with these wolf jaw tongs, again, so that the steel comes down the middle of the tongs and then out one of the side jaws. This is a very secure grip. If I'm trying to hold it like say this, which I see very common, stuff tends to move around on you a lot, it's much less secure. So go in, grab it on a corner like that, and you'll be good to hold it. Let's heat these up and we'll work on the front end of them here. All right, we've got it hot. We're going to come in here. We're going to hammer. Just kind of stretching out that steel bar. And what you can see I'm doing is I'm trying to leave the outside thick and bring the inside into a taper. I'll take another couple hits on that. Really taper it around. You can see how much thicker that outside is than the inside edge. We're then going to flip it over. And because I did a lot of chatting, we're actually going to put it back on the fire. We'll do the same thing to the other side. Come here, spread this out, drop it off the anvil a little bit, try and really stretch it. Once we've got it here, we're going to bring it to the horn, lay over just the spread out part, and give it a sharp blow to bend it down. Flip this over, do the same thing on the other side here. What I want to wind up with is those two pieces overlapped like this. So you get kind of, I think of it as sort of a teardrop shape, but you can see we've got those thick areas on the outer edge, the thinner piece going down the length of the bar, and everything nice and lined up there. So this one looks great. Let me get the other one ready and I'll be back to you in a second. All right, we've got our chain link ready to be welded up here. So we're gonna put this in the fire, start getting it hot, and let's talk a little bit about the forge welding process while this warms up. So the key to forge welding is really getting the steel hot enough that the surface of it starts getting a little molten-y. You hammer that together, and if you do that successfully, then when it cools down, you've got a single piece of steel. The biggest challenge I really see when people are learning to forge weld that prevents them from getting good forge welds boils down to the steel is either not hot enough when they pull it out of the fire, or they take so long that by the time they hammer it, it's no longer hot enough once those hammer blows come to push it all together, or they hammer it so hard that it just kind of blows everything out. This steel is the hottest we're ever going to be working with it. If you hit it hard, you are really just going to flatten things out and you're potentially going to mess up your forge weld. So we need firm but not super hard taps. Optionally, for mild steel, we've got this stuff right here. This is borax, 20 mule team borax. You can buy it in the laundry aisle. I think it keeps your brights brighter. It's called flux. There's a wide variety of different fluxes out there that you can use. Some people use sand or very complicated mixes of ingredients. I'll just use borax most of the time if I'm going to use it. This is mild steel. This first chain link we will use a flux on it so you guys can see what that process looks like. Honestly though, when I'm welding up mild steel, I normally don't bother using flux. What the flux is going to do for you is, one, it'll melt onto your steel and it will provide kind of a glassine coating over the steel, which will prevent oxygen from getting to it, which will reduce the amount of scale that builds up. Scale is not weldable, so if you've got a weld with a piece of scale in the middle, you've got an inclusion and you've got a spot where it's not welded. The flux will also help lower the melting point of that scale a little bit, which can make it easier to get all that into a liquid form and pushed out so you can get a good clean weld. Mild steel starts getting ready to weld just before the temperature that scale melts at. And so if I've got a pretty reasonable piece and I don't mind getting it a little hotter than I technically need to for welding, then I won't bother fluxing it. I'll just go straight in and weld it up and try and take it up a little bit hotter so that that scale gets to liquid and can get pushed out of my weld. And I get a nice weld without having to flux. When I'm doing chain links, a lot of times I'm doing a lot of chain links and I try and make it as fast as possible. And the extra step of heating it up, brushing it, putting flux on it, I just find is not worth the extra time for any difference in quality, which I don't really notice on these chain links. But let's get this hot and we'll bring it out, we'll brush it, we'll flux it, so you guys can see what that looks like. We'll put it back into the fire and we will weld it up. All right, that's looking hot enough for fluxing. So let's grab it and pull it out of the fire. I'll bring it over to the anvil. I'll brush it down a little bit, really trying to get the bristles on this brush down into the middle of it. And then I'm going to take a little bit of flux. I'm just going to sprinkle it on there. Flux is not glue, so having extra is not really going to help you. So just a little sprinkle here. You'll see it's melting and it's kind of bubbling up. We keep this out here in Texas opened up, so it gets a lot of moisture absorbed into the flux. You can buy anhydrous borax. Actually, get a shot in there. You can see kind of that glassy coating and it all melted on there. So that's looking pretty good. That's ready to go back in the fire. You can sprinkle flux directly on while the piece is in the fire if you want. If you've got a nice long spoon, something like that. But as I was saying, this borax, we keep it out here in a can, so it picks up a lot of moisture and it'll bubble up and puff, and that's all the water being driven out of the flux. If you're in a drier location, it might be worth getting anhydrous borax, which is the same stuff, just pre-baked, so there's no water in it. It won't bubble up in the same way that this borax will. But with our Texas humidity, trying to keep it dry really just doesn't make sense. We may waste a little bit, but borax is pretty cheap, so it's not a big deal. So I'm going to start getting this hot, and I'm going to need to pay close attention here while I'm getting it hot. I've got it down in there. My fire could be a little bit better, but it'll work well enough. And I'm going to give it a bunch of air, and I'm going to get it up to a bright white temperature. What I'm going to look for in this steel is for the surface of it to start, in my view, looking kind of like melted butter. So if you took a piece of butter, you set it out on the counter on a hot day, and it starts getting kind of glossy on the surface of it, to me, that's what steel, when it's up at forge welding temperature, looks like. I will also look for little bits of scale and stuff like that, which will look like dark spots on the very bright piece of steel. At some point when it gets ready for forge welding, those little bright dark spots will just melt away. And as soon as I see that, I know my scale's melted. I'm ready to go in and forge weld and have a nice clean weld. You can do that with mild steel. High carbon steel we'll talk about in another video. It's slightly different forge welding process, because it welds at a lower temperature. So we're going to get this hot. I'm going to try not to look too directly into the fire. It does throw off some levels of UV radiation. So some welders' goggles with a very low rating would not be a bad idea here. Something to protect your eyes a little bit. This is starting to get pretty warm here, so I'm going to keep a close eye on it. If I start seeing some sparks, that's another sign that I'm right there at that forge welding temperature. If I'm worried that the whole piece isn't at a forge welding temperature, but I am already starting to see sparks, what I might do is stop the oxygen, stop the air going through, let it wait for a second or two, and then pull it out so that I can get the whole thing up to forge welding temperature. The bottom of a piece of steel tends to get hot faster than the top of the piece, so you can flip it around or let it soak a little bit like I was talking about. We're starting to get real close. I see a couple sparks in there. I'm going to grab this. I know where my hammer is on the anvil. If you want to focus on the anvil, hot steel, and we're going to drop it. Because I dropped it there, it's already cool enough that I'm not going to bother hitting it anymore. What you saw was a couple hits on one side, flip it over, should have been a couple hits on the other side, right back into the fire. We've got 3-5 seconds maybe at forge welding temperatures, so a couple hits is all I'm going to get. Back into the fire to get it back up to forge welding temperature, finish up that weld. You'll notice I did not flux it when I put it back in. It is closed up now, so adding flux on the outside of it's not going to do a whole lot. All right, we are good and hot. If you'll go back to the anvil, hot steel, couple taps on each side. I'm going to bring it here to the horn of the anvil, and all I'm really doing is kind of shaping this. I like my chain links to be pretty round, so I'm just going to work on rounding that off. Looking at this, I can see a little bit of a line right there. I'm actually going to take one more welding pass on this. And just get everything nice and lined up before I do that. Typically when I'm welding chain, I do 2 welding passes, right? Put it in, bring it out, couple hits on each side. I'll clean it up a little bit on the horn as pass 1, straight back into the fire, back up to a welding temperature. Same thing again, just to really solidify that weld. It's looking pretty good. Firm blows, but not too hard, right? I don't want to smash this thing and really thin it out. Set it back in on itself a little bit, try and make it nice and round. Doing some blows kind of at an angle here to knock the corners in. Drop it on the ground again. That's always a key part of the process. That's looking pretty good. Give it a couple blows here to adjust the shape. I've got a little bit of a bend there. I can take that out probably by coming here and just working it back on the horn a little bit. That's a little bit better. And I think I'm pretty happy with that. So let's quench this and take a look at it here. Get it good and cool. And I'm going to take a look at this weld. So I'm actually set this on the anvil so I'm not moving it around while you guys are looking at it. And this weld looks pretty good. We can see a little bit of a line right there. That's pretty common on handmade chain. Most of it's gone through there. Really, to get rid of those lines, you got to have it hot up at the welding temperature and kind of work through those areas to make sure it's all smoothed out and welded. I'm not going to bother with it. I am very happy with how this looks. Now, am I 100% sure that I've got a perfect weld? No. I mean, this looks good. I am very confident that it's a good weld, but if I really wanted to test to see whether or not I've actually got this welded, I'd have to do something destructive to it in order to test it. So I might do something like grab it and hammer on it until I either completely collapse this or it pops open. If you can pop this and it pops along the weld line, you didn't have a good weld. But we only really get that with destructive testing, and I'm pretty confident that this one's good. So I've got one link and I've got my hook, and I need some way to join these together. So I'm going to get another link ready where I've got the ends squared out or flared out, and then I'll show you how to join these two pieces together and a couple tips for welding when you've got stuff hanging off the piece that you're going to weld up. So 1 second and we'll be ready to show that. So we've got this next chain link hot and ready. We're going to pull it out, take our first chain link, slip it on there, take our second one, slip it on, bring it here to the horn of the anvil, and same thing, hammer that down, hammer that down. Just work it back and forth a little bit until we've got those nicely overlapped. You can see I've got a little bit sticking out here over the edge. I want to, if I can, try and knock that back in. Anything that we've got kind of hanging out over the edge, there's nothing for that to forge weld to. And you know, we want all of this end piece here to really weld up nicely. So we've got this ready to go in for the forge weld, but we've got some stuff hanging off of it, which is going to make this a little bit trickier. So we're going to go in and we're going to make sure that we've got both our link and our hook hanging off the back end into the fire with just the welded piece in the hottest part of the fire. Once that's up to welding temperature, we're going to pull it out over to the anvil, couple hammer blows, and then we're going to make sure to flip it in this direction and a couple hammer blows. The key that we're looking for here is we want to flip it with these hanging down over the edge of the anvil. If I flip this the other direction, well, if I flip it the other direction without dropping it, if I flip it the other direction, then everything's going to get all messed up and I'm not going to be able to get those hammer blows in easily. So it is push it up on the anvil so this stuff is forced down off the side, and then I rotate it, keeping that stuff down off the side so that I can get my hammer blows in. Let's go ahead and get this hot. You may have noticed on the first one too, when I go to do my forge welding, I make sure that I know exactly where my hammer is going to be, the direction it is, so that I can pick it up and be 100% ready. And a lot of times, especially with smaller steel, I'll kind of pull it out of the fire, be positioned in between my forge and the anvil, and go to hammer without even having to take a step. Need to do this very quickly so that it doesn't cool down too much and get below forge welding temperature. Like I said earlier, if you're struggling with the forge welding, it's probably because your steel is not hot enough when you're coming out of the fire, or you're dilly-dallying as you come over here and you find your anvil and you finally get in to give it a hit, and it's dropped below your forge welding temperature, and so you don't get a good weld. So this is a good thing to practice that out of the fire onto the anvil, and a firm yet not overwhelming hit while it's cold and you don't have the pressure of the forge weld. All right, we're starting to get pretty close here. I see a couple sparks. I can't see my steel, so I'm just kind of going off that. Grab this. Couple blows, rotate. Couple blows here to the horn. Tap it in a little bit, just clean things up. Back into the fire. We're going to take one more pass at that. We should be good. I see a few sparks coming up. It's probably a little bit of steel that melted down in there. I don't believe my piece is hot that quickly getting back in, but we are definitely going to keep an eye on this. So I can see my piece of steel there. That is looking hot enough. Hot steel. Couple taps. A little hotter than I really probably needed, but that is okay. Come in, clean this up. I'd like it to be a little bit longer of an oval, so I'm just going to set it on the side. Give it a couple taps here to make that a little bit more of an oval. Make sure it's looking nice and flat. A little more cleanup here on the horn. That's looking pretty good. Let's go ahead and quench this whole thing off. Take a look at it. So we've got our weld there. I'm going to flip this over. A little bit of a line right there, but overall, and that looks like it's probably a pretty reasonable weld. So I'm going to call that good. And once you've done this, you will have officially passed the 2.0 class that we've got out here. We focus a lot on practicing this forge welding. So I try and give folks a whole day to do this and encourage people to make as many chain links as they can. I think about the most I've seen somebody make is 10 links, maybe 11 links during the class. But forge welding really is, it's not hard to do if you do everything right. But there are a lot of things that you do have to do right in a very short amount of time, right? So focus on getting it up to the right temperature, keeping your fire clean, having the time from the forge over to the anvil to hit it be as short as you can. Hit it firmly, yet not overly hard, and just do it again and again. And as you make these, you can do what I did, which is break a bunch of them, test them, see whether or not that weld is really good. If it is, you should be able to do things like put this into a vise, bend it 90 degrees cold, and then bend it back 90 degrees and not have that weld pop on you. Or you could cut one end of it here and then spread it open and see whether or not that weld pops. Just anything you can do to put stress on that weld and see if it's going to come apart. The really nice thing about chain links is as you get good at them, you can make them very quickly. They're not expensive to make. It's a pretty small amount of steel. And so if you mess one up, you throw it away and you start over again. And that is exactly the kind of project that you want to look for as a beginner. When you really get good at this stuff, or you really want to practice it, you can do what I did and make a long length of chain. So we'll come out here and take a look. Right, this whole length of chain right here, I made all this by hand, starting with 10-foot lengths of 3/8 inch rod, using a hot cut, cutting it all through the fire, and then building it up link by link. If you are making a longer section like this, what you'll want to do is come in and make an individual link, and then it would actually be these two links here. I'd make a link, I'd make another link, I'd make a third one to join them together, and that gets you a length of 3. You make a second length of 3, another one to join them together. Now you've got a length of 7, and you just keep doing that over and over again. You don't want to have a lot of this stuff dangling off your tongs as you're going back and forth to forge weld. And with that technique, you're doing as many as possible as single links or as shorter lengths of chain. But you can just keep building it up. And then eventually at some point, you'll either need a friend to help you, or you wind up right where you're coming in somewhere here in the middle, trying to forge weld this whole mess together. Got it wrapped around your shoulders with the tongs, going back and forth to the anvil. It does get a little bit crazy, and you can see why trying to keep things as short as possible as you're putting it together makes a big difference. But this is wonderful practice for forge welding. You make a length of chain that's 30, 40 links long, and you will be very confident in your forge welding skills once you're finished with that. So go out there, make the hook, make the chain links, practice all those skills that we showed you in the 1.0 series and the 2.0 series, and you'll have a good foundation to build on for other blacksmithing projects. Thank you guys so much for joining us out here through these 2 series. We are going to start up some other series now. I'll get a video posted shortly talking about the other things that we're going to be doing as well. If you have any questions, please do drop them in the comments. I will respond to all the ones that I respond to. And have fun and keep the fires hot. Thanks.